I'm Marty, and I'm in your class.
I'm Isabel, and I'm her stepdaughter.
And today we're going to be doing science! Today we're going to be looking at what happens when matter changes states. Who remembers the 3 states of matter? Isabel?
Volume, mass, and weight.
Good guess.
No.
She does not remember the 3 states of matter. Okay, well that's good. So here's what we're going to do. I am going to demonstrate taking solid water, chocolate chips, and margarine separately, and putting them in the microwave, so I would be adding heat, to see what happens. Okay, well, off camera, I just want you to know Isabel did redeem herself when I talked about putting ice in the microwave. She said, "Oh, is that a solid, liquid, and gas?" And I said, "Ding, ding, ding, yes. You know about the 3 states of matter." So here we have a container. We have my scale. And there, now it's showing 0 ounces. I'm gonna put in the container and solid water, better known as solid ice.
Oh my god.
And this weighs, oh, where's my pen? Pause it. Okay, so the container and the ice cube are 10.2 ounces. Now we're going to put it in the microwave. And I'll turn it on for 30 seconds. Pause.
Oh, what?
Okay, Isabel. So while the ice is in the microwave, I wanted to ask you to make a prediction. What do you think will happen to the ice while in the microwave?
It will melt.
And turn into a
Liquid.
very good. Okay. Now, how about the fact that I weighed it first?
That's just
What do you think will happen to the weight of the ice when it turns into water?
decrease.
It'll decrease?
Yes.
Okay, we'll soon find out.
Okay.
Okay. And here we have
Liquid.
liquid.
Darn it, it's gonna increase.
Now it's water. Now we're going to weigh it. And ding, ding, ding. It's exactly the same.
I wasn't wrong, but I wasn't right.
Well, yes, you were wrong because you said it would decrease, which means get smaller, but it stayed the
said.
same. No, folks, you saw her. She said decrease.
You know, it's not cool.
Okay, so 10.2. Now, what do you think will happen if we put it back in the freezer?
Just gonna turn into a solid again.
And what do you think will happen to the
It will
weight?
stay the same.
Okay. Next, we are going to try chocolate chips. Now, since I need to stir the chocolate chips, I will also put a toothpick in here to weigh initially. And let's see what the weight is. 10.7 ounces. And I'm going to write this down. Isabel, what is your prediction? Do you think when I put the chocolate chips in the microwave, first of all, what do you think will happen?
It's gonna melt.
They're going to melt.
But then it's gonna increase.
And what do you think? What?
Gonna increase in weight.
It's going to increase in weight. Okay, very good. Let's film this. Okay, so here we have our chocolate chips that have been in the microwave, and they are a liquid now.
They look delicious.
They do. So, I also am going to just leave this in there. Now, we're going to weigh it and see. Did it increase, as Isabel suggested?
Oh my god.
Now, it was 10.7, and now it seems to be 10.4. And folks, that is not how it was supposed to turn out, so let's try this again. There we go.
Oh my God.
There is a little bit of variance to this scale. It stayed the same.
No, I think it is gonna be more because it's a sugar. So just thinking.
Okay. Now, what do you think will happen to it when I put it in the freezer?
It's gonna turn into a solid again. Or if you leave it out for an hour or so.
Right, you're right. I wouldn't have to put it in the freezer. If I just left it at room temperature, it would turn back into a solid. What do you think will happen to the weight
It will
when
go
it
back
freezes again?
to the same.
It'll stay the same?
No, actually, no. It's probably going to be more because it's going to be harder, which harder things are. Ooh,
Harder things are
just more
heavier.
heavier,
Okay.
more elastic.
Okay. Okay, the next thing we're going to do is, no, I'm doing this in the wrong order.
Oh.
Okay, next, as promised, we are going to take margarine that's in a solid form, and we are going to weigh it, and we're also going to weigh the lid before we put it in the microwave, and that looks like it's 0.8 ounces. Now, the reason why I decided to put a lid on it is when I was practicing this yesterday, and I just put it in the microwave like this, all of a sudden it popped and splattered all over the inside of the microwave. And then, of course, not only does that make a mess, but also it throws off your results. So here we go, melting the margarine.
It's going to turn into a liquid.
Isabel says it's going to turn into a liquid, and what do you think will happen to the weight?
Do we have to?
Yes, we have to keep doing this. This is the last one.
Right.
Do you think
I'm
the
gonna
weight will
say-
increase, decrease, or stay the same when the margarine is melted?
Stay the same.
Okay, she's going to say stay the same. All right. You can pause. Okay. So the margarine is melted, and we're going to weigh it again. And we will see. It says 0.7 ounces this time. Let's just turn it off and try it one more time.
I better be right. Yay!
There we go. It stayed the same.
Still don't want to do it again.
Okay, now, what do you think will happen? Make a prediction when it turns back into a solid, and I will put it in the freezer just to make that happen faster. What do you think will happen to the weight? What do you think will happen to the liquid margarine? I guess I already gave it away.
Just gonna stay the same
It's
again.
going to stay liquid.
No, it's gonna freeze.
How about if I just left it out on the
It's not.
counter?
It's not gonna do anything. It's just gonna be a liquid,
Okay.
unless if it spoils.
So you think if I just leave it here, it will remain a liquid?
Mhm.
And how about if somehow we could turn it back into a solid? What do you think would happen to the weight?
It stayed the same.
Okay, she thinks it'll stay the same. All right. All right. Well, we will test out that other question as well. Okay. Now we're ready for the next part. Now, the next thing we're going to do is put some salt in some warm water. Isabel, what do you think will happen when we put salt into warm water and stir it?
It will dissolve.
You believe it will dissolve, okay? All right. So here's the warm water. Or did I already do that? I'll do it again. Okay. Now, we need to weigh the water in the container. And that weighs 8.4 ounces. Water in cup. Now, we also need to weigh
The salt.
the salt, but
Salt doesn't
I
really
forgot.
weigh anything.
Well, it does weigh something, not much. Okay, but in order to know how much the salt weighs,
You have to weigh the cup.
we have to weigh the cup. And the cup by itself weighs, oh no, I did that wrong. Hold on. Sorry, folks. Technical difficulties. The cup by itself weighs 5.9 ounces. And with some salt, It now weighs 6.0 ounces. So Isabel, how do you find out the weight of the salt alone? If the salt, well, and the cup weigh if the cup alone weighs 5.9 ounces, and the salt and the cup weigh 6.0 ounces, you can use the pen. How much does the salt weigh?
Well, if you take out the 59, technically this was just 1.0 or 0.1 ounces.
0.1 or 0.1?
0.1.
Right. So you did what form of math?
I just subtracted.
You just subtracted. You took the total amount and you subtracted the cup and you came up with 0.1 ounces for the salt. Okay, so we're going to add the salt. You can get nice and close. We're going to stir it. It's a little hard to tell with this white scale. Let's just take it off of here and stir it on the green counter. Can you see from that angle?
Yep.
And tell me when you think it's all dissolved. Maybe I'm gonna
quite
use-
yet. Oh,
I'm just gonna use a spoon. I think this will go faster. Okay. Is it dissolved?
I believe so.
Okay. Now, my next question is, Isabel, did it disappear?
Mm-hmm.
Okay. She says yes, it disappeared.
Well, not really. Technically, it just soaked into the water.
Okay. How could you test whether or not the salt dissolved or disappeared?
By weighing it again?
Well, we are going to weigh it again to see if it changed, but how else could you test it using one of your 5 senses to know whether salt is still in there or whether
Touch.
it's gone?
Touch.
You could tell by touching it? Okay, try that.
Oh.
Can you tell if it's salty?
Well, probably by your taste.
Probably by taste. Why don't you taste it and see? Just stick your finger in there and taste it.
What's
See
it
if it still tastes, if it tastes salty.
Yeah, it does.
Okay, it does. I forgot, Isabel. I wanted you to predict what you think will happen. Besides that the salt dissolved, you were correct about that. Show this. If we have the water and the cup weighing 8.4 ounces and the salt weighing 0.1 ounces, altogether, those two items weighed 8.5 ounces.
Mm-hmm.
Do you think, now that it's dissolved, it's going to weigh less, the same, or more than this?
Gonna weigh the same because they're all together.
Okay, she predicts the same. And here we go.
Oh, you got. Oh.
And ding, 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 8.5. She is correct. Okay. Pause. Now, just for fun, we're also going to melt some more margarine and then leave it sitting on the counter to find out if it stays liquid or turns to a solid. Okay, there's the melted margarine, and we will check back much later to see if it is still a liquid or if it turns into a solid. Isabel wasn't quite sure if it's fair because the air conditioning is on. Okay, you're on camera. Okay, Isabel, because I'm just learning to do this, I forgot to ask you an important question.
Yes.
And that is, after the ice and when we did the ice and the melting experiment, and what would you say if I asked you what was done? How would you describe it? What did I do?
You made solids turn into liquids,
Okay, so I took an ice cube.
and turn into water. You took chocolate chips and turned them into like
Okay, so let's do it thing by thing with the chocolate chips. Okay, what did I do? I took a container.
of chocolate chips.
No, I took a container, a glass bowl.
Oh, of salt. I'm sorry.
Okay,
I'm lost.
let's talk about the chocolate chips. Let's just go through that one
Okay.
So we took a glass bowl. What did I do next?
Yeah, filled it with chocolate chips.
Okay. Then what did I do?
Then you weighed it.
Then I weighed it.
And then you put it in the microwave for 30 seconds.
Okay, and
Then you stirred it up to turn it into a liquid.
is that what turned it into a liquid? My stirring it?
No, the microwave, the heat.
Oh, the heat did. Okay, good. All right. And then what did I do?
Then you put it in the freezer to turn it back into a
Well,
solid.
first, before I did that, I did something again on the scale.
weighed it.
I weighed it again. And you made predictions. Okay. And we did a similar thing with the ice and with the margarine.
Mm-hmm.
How about with the salt? What was done in that experiment?
You heated up water
Mm-hmm.
and then you poured it into a glass bowl. But first you weighed the bowl. It's without the water in it, I believe.
Well, I weighed the bowl without the salt in it.
Oh, well then you weighed the bowl of water and then you added the salt. And then after you did that, you stirred the salt, which made it disappear because of all the heat in the water.
Oh, so you think the salt would not disappear if we did it in cold water?
Yes.
Oh, that's another experiment for another day, though. We won't do all these experiments today. Okay, and then what happened after I was stirring it for a while?
All the salt disappeared, but was still there in taste form.
So did it disappear?
No.
What did it do?
It just dissolved into the water.
It just dissolved. Now, can you tell me anything more about that? Like, have you ever seen anything else dissolve into water before, or other experiences you've had with that process?
Nope.
Let's see, what do we like to drink of a lot around here? It's yellow.
Oh, lemonade.
Lemonade. Now, when you make lemonade and you open up that packet, what's inside?
Powder.
Powder. And you do what?
Stir it. And
You
the
stir powder in a pitcher
Yes, full of water, and it mixes in.
and it mixes in, so it
Water powder? I don't know.
it dissolves.
Oh,
So you do know something else that you do on a regular basis. You add the lemonade powder to water, stir it up, and it dissolves.
Mm-hmm.
It doesn't disappear because, boy, it does taste a lot better than just plain water, doesn't it?
Yes.
Okay, last we are going to make Play-Doh. Now, I did teach preschool for the last 11 years, and I made Play-Doh 9 times a year, once a month. And so I had only made 99 patches of Play-Doh, so I figured we'll make it an even 100 by making Play-Doh today. Here you go, Isabel, you can take the camera. So I put my pan on the scale. Whoops, let's try this again. I put the pan on the scale. Now the scale does something fancy. If I put this pan on first, it just shows me 0. So now I'm only what the number in ounces it's going to show me is the weight of the flour and the salt and the other ingredients. It's not going to include the pan because later we just want to measure the weight of the Play-Doh and not the pan. So that's a pretty handy dandy feature. So first we need 2 cups of flour. And if you have young children or grandchildren, this is the most awesome Play-Doh recipe ever. It can be doubled, which I did for my preschool class. Okay. The flour weighs 8.6 ounces. And now we're going to add 1 cup of salt.
That's a lot of salt.
It is a lot of salt. That's why Play-Doh does not taste very good when you try to eat it.
I don't
Okay.
know who would ever want to eat them.
Now, that brings us up to 1 pound, 3.5 ounces. Now, we're going to put in a little bit of food coloring. I don't know if this will even make a difference in weight. It didn't. Okay, but I just wanted to add that while it was on the scale to make sure we didn't goof anything up. We need 4 teaspoons of cream of tartar. This is the magic ingredient, folks. In Play-Doh is the cream of tartar. This is what keeps the Play-Doh soft. Of course, that and keeping it in an airtight container. 2, 3, 4. That brings us up to 1 pound, 4.3 ounces. And now I need to add 2 cups of water. That brings us up to 2 pounds, 4.8 ounces. And last, we're going to put in, how many? 2 tablespoons of vegetable oil. Which brings us up to a grand total of 2 pounds, 5.8 ounces.
Do I get to stir this?
Sure, you can even cook it.
Why is that?
Okay, now, but before we do that, we're going to make one more prediction. So this is how much the ingredients weigh before cooking.
Okay.
After we stir this on the stove, and first of all, a couple of things. What other prediction? You've seen me make Play-Doh before, so this is not that hard of a guess for you. But right now, it's a combination of liquids and solids.
Mm-hmm. And powders.
And what?
Powder.
Well, right. The powders are a solid. Yeah. Although they don't hold a certain form. I think that has a special name. Anyway, what do you think it will look like after I cook it?
It'll turn into a solid.
It will turn into a solid. How about the weight? What do you think will happen to the weight?
It'll all add up to something bigger than 2 pounds and
5.8 ounces.
5.8.
So you think it will be heavier?
Mm-hmm.
Okay. Here we go. You want to stir it?
Sure.
All right. Get a wooden spoon. Oh, you got it.
Well,
That one's fine. All right, we're just going to get a little bit of this and then I suddenly realized that we didn't want to knead it in flour yet before we weighed it because that would throw off our weight. So it was weighing 2 pounds, 5.8 ounces. Isabel predicted it would get heavier when it was turned into a solid lump of Play-Doh. And the answer is
No.
2.58 ounces. It's exactly the same. So Isabel,
I don't want to know.
when you think about what happened to the ice, what happened to the chocolate chips, what happened to the margarine,
They all stayed the same.
they all stayed the same. So if each of these are different kinds of matter, what do you think we could say that would be true of all types of matter when they change states? So when it goes from solid to a liquid, liquid to a solid.
They all stayed the same weight.
They all stay the same weight, no matter what state of matter they're in. Now, in 4th grade, we don't learn about gases. Do you suppose if you weighed a cup of water and then you boiled it into steam and caught the steam, it would still weigh the same amount?
No.
It doesn't seem like it. It seems like gases would be lighter, doesn't it?
It weighed literally -0.
Well, we'll have to see if we can get a way to figure that one out. Okay, here's Isabel playing with her Play-Doh. Now, Isabel, one more prediction before we're done.
What?
And that is, do you think, let's weigh this Play-Doh as a ball. Well, let's turn it on. It doesn't have to be a perfect ball.
Well, what if I wanted it to be a perfect ball?
Okay, close enough. And let's see how much it weighs. Oh, it's on grams. I was going to say something is terribly wrong. Hold on. I'm going to turn on ounces. Wait till it gets to be all zeros. Okay, now 2.57, so maybe a little bit is on her hands now. Okay, now, do you think if we change the shape of the Play-Doh, for instance, you rolled it into a long snake,
Hold on.
it would change the weight?
Oh, I almost got it, but okay. Yes.
Okay, what do you think will change? How will the weight change?
It'll go up 1 because it's getting all the stuff off my hands.
Well, no, not because of that. Just because we're changing the shape. So it's going from a big blob to a long snake. Do you think that's going to change the weight of the total amount of Play-Doh?
Yeah, that's a snake.
Okay, what's your answer?
No.
Not going to change the weight, okay? The matter,
Can you turn it on?
it's on. It's still on. Well, now you just, okay, take it off. It was on, it just took some minute to, okay.
Told you.
And it stayed the same. Okay, and we have here the re-solidified liquids. So this water is turned to ice, the chocolate chips have hardened, and the margarine that went into the freezer is now a solid. The extra margarine that we are sitting on the counter to do our additional site experiment is slowly cooling, so we'll leave that one back there. Okay, so starting with water, the ice cube that was made water that turned back into an ice cube, 10.2, right on the money. And the chocolate chips, which were 10.7 ounces before, show 10.6. There's 10.7. And the margarine, which was 0.8 ounces before, is now, that's not right. Well, that's curious. Let's turn it off and try it once more. .6. Well, Isabel is no longer with me to make any additional predictions or guesses as to why that happened. I do not know. Now I remember, I forgot the lid. So it is the same weight, 0.8 ounces. The science standard covered here under physical science for 4th grade, the topic was electricity, heat, and matter. And it explained, this topic focuses on the conservation of matter and the process of energy transfer and transformation, especially as they apply to heat and electrical energy. And the specific content standard that I was focusing on was the total amount of matter is conserved when it undergoes a change. And then it described further that when an object is broken into smaller pieces, when a solid is dissolved in a liquid, or when matter changes state, solid, liquid, or gas, the total amount of matter remains constant. And they noted that at the 4th grade level, this should be limited to the observational level. And also at 4th grade that the NAEP 2009 Science Framework suggests, recommends that using the more familiar term weight in elementary grades would be appropriate, and to save the introduction of the word and concept of mass until middle school. Bye.